Guys, today we're going to be talking about using Pascal's triangle for binomial expansion. Now this is really useful and it's a good skill to learn, so let's get into it. Before we can go ahead and start expanding binomials using Pascal's triangle, we first need to know how to write Pascal's triangle. And an easy way to do this is to start out with 1, 1, and 1. If you can do this, you can get the remaining numbers of Pascal's triangle. And how we do this is very simple. So we start out with our 1, 1, and 1 in this form. And we simply just write a 1 on the outside. And then we say 1 plus 1 is 2. And then we write another 1 on the outside. And then we go down a row. Okay, start the process again. Write a 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3. And then again, write a 1 on the outside. Go down a row. Write a 1 on the outside. 1 plus 3 is 4. 6, 4. So you can see the pattern. This is beginning to take, right? And you can do this as long as you want. Okay, we'll stop here. And what each one of these rows means, okay, pertains to a degree. So for example, the first row is when you have a degree of 0, or an exponent of 0. The second row is when you have an exponent of 1, or degree of 1. Okay, third row, degree of 2, 3, 4, 5, and so on. Okay, so you're going to want to know how to create this triangle, and you're going to want to keep it on hand when you're expanding binomials. So now that we know how to write Pascal's triangle, let's look into a problem of binomial expansion. So let's say we have x plus y to the third power. And they want you to expand that. Now you could go ahead and do this, right? X plus y, x plus y, x plus y, and do all that math out. That's a lot of work. Or you could use Pascal's triangle, and that is what we're going to do here. Now remember, the row that pertains to a degree of 3 or an exponent of 3, we're going to write that as 1, 3, 3, and 1. Okay? So you need to know that, and that pertains to a degree of 3. Alright. So what we want to do now is go ahead and expand this. Now this is very simple. Okay? So you start with your x value, and notice how we have a 1 here. So we do 1 times x, which is just x, and then raise it to the third power. Next, we do 3, so plus 3 times x squared times y. Now, can you see a pattern that's going to develop here? We started at x to the third power, and then we went down a degree, and then the y came in. This is really to a power of 1, right? I'm not going to write that there, I'll erase that. And we simply write that constant 3 in here. Our next one will be plus, again, here comes a 3. And what do you think is going to happen to this x squared? Well, it's going to go down, so it's going to be x to the first power now. And the y will gain an exponent. Okay? Going on to our next one, we just have 1, so we write plus. Now what do you think is going to happen here? This is x to the first power, so it's going to lose 1, so it's really going to be x to the 0 power, just 1. And this will gain 1, so it will be y to the third. You can see the pattern here. Okay? Let's try another one, and we'll keep it simple. So all I'm going to do here is change the degree of the exponent to 4. Okay. And let's erase this. And then if you look at your triangle, For a degree of 4, we're going to have 1, 4, 6, 4, 1. So we have 1, 4, 6, 4, 1. And this is for a degree of 4. Again, so you're going to do business as usual. Again, can you imagine how much work this would be if you had to expand this all out? Simply by doing x plus y, right? X plus y, right? And you have to multiply that all out. That's a lot of work. This is why Pascal's triangle is so powerful. So again, we're just going to use this right here. So we start out with 1. We know we're going to start out with the x as well. So it's going to be x to the 4th power plus, now here comes my 4. And again, we know this is going to continue to go down a degree. So x to the 3rd, and then we gain, right, for the y. Plus, now I have 6, and go down a degree on the x. And we gain 1 for the y, so y squared. Alright? Plus, lose 1 for the x, gain 1 for the y. Alright, and the last one is 1. So we're going to lose the x entirely, and this just becomes y to the 4th. And you see how simple that was rather than multiplying it all out. Alright, this would be your answer right here. We just expanded it. Alright, so Pascal's triangle is very powerful. So it's good to have that knowledge. You can kind of fall back on that when you're dealing with binomial expansion. These were pretty simple. Sometimes they get a little more complex when you have actually values in front of the x or the y or whatever variables you're dealing with. And I actually will make a video on that in the future. Okay, but this is Pascal's triangle, so really good stuff.